Hi folks, we're doing some more mathematical induction proofs, and these are going to be trig products, and these something a little bit different to compared to our earlier viewings. So some people think these are pretty tough, but you make up your own mind. You might not find it as hard as it initially looks. So I've started the ball rolling. So we've got an example where n is a positive integer. Prove that provided sine theta doesn't equal 0, that bunch of terms multiplied together with the cos on the left, culminating at cos of 2 to the power n minus 1 theta equals sine 2n theta over 2 to the n sine theta. Now, don't panic. It's actually, yes, it's a little different, but if you break it down, you can see that these are just like multi-angle trig terms that you've seen before, and that's the general term there. Okay, so 2 to the n minus 1 times theta, it's the cos of all of that. We're going to use some of our trig identities from our trusty formula sheet as well in this, and so always, if you have access to them, always utilize those. So we'll call the proposition P of n, and let's start. Just to speed things up, I've done the initial step there. You can see that we get 2 to the, using the general term, 2 to the 2 to the 1 minus 1 is 2 to the power 0. You can see that right there. And subbing in n equals 1 elsewhere, the left hand side just comes out as cos theta, because it's 2 to the power 0 is 1, so cos 1 theta or just cos theta. And by using sine 2 theta equals 2 cos theta sine theta, we can facilitate that cancellation there, so it holds for the initial step. So let's try assuming P of k so when n equals k, assume P of k is true. So P of k would be cos theta, cos 2 theta, cos 4 theta, cos 8 theta, equals sine 2 to the k theta over 2 to the k sine theta. And now we synthesize our p to the k plus 1, very much the same things. So up to there is what we had on the previous line, and the next term will be when we have k equal to, well, n equal to k plus 1, I should say. So put that extra term on, inductive term. So k minus 1, or n minus 1, when we have k plus 1 subbed in for n, is 2 to the k. It's one more than the previous one, which makes sense because these are all going up in powers of 2, each of the angles, the parameter on the angle. So we should get that on the right hand side. Okay, that's what we're required to prove simply by substitution there. Okay, but you see, by going from the line where we have P of k to P of k plus 1, it's simply inducing the next term on. So the difference between these two lines here is the actual inductive term being multiplied on. So that term there highlighted in green is what we're talking. So if we do the same to the right hand side, so going from the line for P of k to the line of P of k plus 1, we have sine of 2k theta over 2 to the power k sine theta there, multiplied by the same thing on the other side, which is axiomatic. Okay, so then simplifying that, or attempting to simplify, we have sine of 2 to the k theta. I'm just going to put those parameters in brackets there. And, oops, I've forgotten a theta. You probably saw that, didn't you? Okay, getting back to simplifying now. Yes, my Wacom tablet's getting low. Should just be enough for this video. Okay, just got to induce some magic out of it. Pray that it lasts. Now we're about to use the same identity. This is the second time in the video we've used that identity. We used it back up here as well, you might recall. So 2 sine A cos A was some real number or some angle, is sine of double that angle or input. Now we don't have 2 times sine A cos A, where A is 2 to the power k theta. We have half of that, so we just have sine A cos A, so it's going to be half of this sine 2A. So we're going to put the 2 on the bottom. Half was 1 over 2. I'm going to put the 2 on the bottom. It's 2 times 2 to the k sine theta, and we'll put on the top the sine 2A part of it, which is sine of 2 times 2 to the k theta. Okay, now grouping those together, something interesting. Now note we're required to prove the expression in the yellow from before, and we're nearly there, because you see, you know that 2 is 2 to the power 1, and we have an index law 1 essentially, so it's 2 to the k plus 1 theta. Okay, which is that. Okay, and we can put it in brackets if you like. I didn't do that before up here. I could have. And down the bottom is exactly the same rule. 2 to the k plus 1 sine theta. It's exactly what we got in yellow. Let me just write our formal statement at the end. And that wasn't really that hard, was it?